All right, we're going to try 0.3. Let's take a look at 19 and then maybe 20 as well. So for 19, the population of the Knoxville metropolitan area is approximately 870,000. And it grows at a increasing rate of 0.9% each year. So we're going to multiply by 1.009. Don't make the mistake of going 09, so that would be 9%. This is 0.009. And then every year. And the question is, approximately how long will it take the population to reach 1 million? So I'm going to solve this graphically, substituting in y for the p and x for the t. And then I'm also going to graph y equals a million, and we will see where these two separate graphs intersect. So over to Desmos, let's go y equals 870,000 times 1.009 to the x. And then let's also go y equals 1 million. Okay, so we're going to have to zoom way out to see what's going on here. There's the population curve. Way out. We should be getting... no, we're still not there yet. There we are. So where do these two meet? There we have it. And hey, at 15.543, 1 million, so about 15.5 years. So about 15.5 years. All right, let's also take a look at number 20. The population of Silver Run in the year 1890 was 6,250. And assume the population increased at a rate of 2.75% per year. So we're multiplying by 1.0275 per year. And I put a T for time. So part A, estimate the population in 1915 and 1940. What is the population in 1915? And what is the population in 1940? So remember that this was the population in 1890. So really what we want to do then initially is plug in for T the number of years out or past 1890 that 1915 is. So that would be what, 25 years? So we're going to do P of 25. So that's going to be 6250 times 1.027. Let's try that again. 75 to the 25th. And we can go to Desmos for that. And actually, we can use Desmos's scientific calculator, I believe. So that's going to be 6250 times 1.0275 to the power of, what do we say there, 25. And that gets us about 12,300, and let's round that up to 15. About 12,315. We'll go approximately 12,315 people. And what about in 1940? So from 1890 to 1940, that's going to be about 50 years. So back to the calculator. Let's change this 25 to 50. And that's going to give us about 24,265 people. 24,265. And for this was part A. Part B of that question, we're looking at approximately when did the population reach 50,000? Let's do that like we did 19 and go y equals 6250 times 1.0275 to the t. And also let's go a y equals 50,000. And let's solve graphically. So 6250 times 1.0275 to the x, and then we want this one to be 50,000. And let's go back home and then zoom way out until we have what we need. There we go. Now let's zoom in right there. And these two curves meet at 76.651 comma 50,000. So we are looking at about 76.65 years. So for part B, about 76.65 years. So the question asks when. So about 76 years after 1890. So that would be around 1960. We'll round this up. So about 1967. And that is the video. Hope it helped.